All right, in the second part of expected value, what we're going to be doing is looking at how expected value can be applied in different cases here. So the scenario in this case is that we had this car dealership, a Honda car dealership, and what we know is in terms of their warranty costs, for an Accord, the mean annual cost is $450, and there's a standard deviation of 215. And likewise, we have numbers for a Civic. So we're going to answer three different questions about this. One would be about the total cost over a 4-year period for an Accord. One would be about a 1-year cost of a Civic and an Accord combined, and then we have another question that will be based on our answer for Part B, using a normal model, where we use normal models and expected value at the same time. So let's go ahead and dive into this here. All right, so in the first scenario here it's what's the mean and standard deviation of the total cost over a 4-year period for an Accord. And what we know is the mean annual cost is $450 and the standard deviation is 215. Also, if we know the standard deviation, we automatically know the variance, because whatever the standard deviation is, in this case 215, the variance will be that number squared. So it'll be 215 squared, which is 46,225, or we can also just leave it as 215 squared. So in terms of the expected value, it's over 4 years. And we're going to write that as, hey, this is the first year, the second year, the third year, and the fourth year. And we do not write it as the expected value of 4A. And the difference is that 4A means it's going to be a 1-year time period, but everything costs 4 times as much. So we don't do that. Instead, this is 4 separate years considered here, and we're going to add the costs together. So 1 year is 450, so we do that 4 different times here, so the answer is 1,800. Next up, we always do the variance before we do the standard deviation because we're going to square root it. So if we do the same kind of logic here, what we're going to end up doing is we're going to take the variance of the 4 years added together. So the first variance would be 215 squared, another variance would be 215 squared, etc., etc. So you wind up with 184,900. Once again, you do not do the variance of 4A, because what would happen is we would actually take 4 squared times the variance, which ends up being not 4 variances, but actually 16 variances here. So there's a big difference here when you get to variance. Finally, for standard deviation, all you do is you take this answer here and you square root it. So the standard deviation, therefore, for year 1, year 2, year 3, and year 4 all added together would be the square root of that, or otherwise known as $430. All right, so that's answering our first question here. Now let's go on to the second one, and this one is about combining the cost of a Civic and an Accord. So you use the same numbers here. We know the mean, we know the standard deviation. The variances would be 215 squared and 112 squared there. So if you want to do the cost, the expected value for an Accord plus a Civic, you would just add these two numbers together. And it makes total perfect sense here. So it'd be $825. Now in terms of the variance, what you would want to do is you're going to add the two variances together. So it would be 215 squared is one variance, the other one is 112. So you'd square each of these, add them together, and you get 58,769, and therefore the standard deviation of that cost combined for one Civic, one Accord would be the square root of 58,769, otherwise known as 242.42. These answers that we come up with, the expected value and also standard deviation, whenever we use a normal model, if we're talking about using these this measurement here of an Accord plus a Civic cost, this expected value is actually mu when we talk about a normal model, and over here standard deviation is actually sigma. So these numbers are extremely useful when we actually use a normal model if we want to check out things about the total cost of a Civic and an Accord. So let's go ahead then and use these two numbers here, 825 for mu and 242.42 for sigma, in the final question that we're going to consider here using expected value. So the question is, if the total costs follow a normal model, what's the chance that the total annual cost of the two cars is more than 1,000? So like we just discussed, we now know mu and we know sigma. Also, we're looking at greater than $1,000. So our normal curve would look like this. Mu is in the middle, 825, and we know 1,000. We want to know what's the chance that it's 1,000 or higher. We're going to end up using the formula that we've used here in the past, where z is x minus mu over sigma. So when you plug in the numbers on that, you'd wind up with z equals 1,000 minus 825, because that's mu, divided by the standard deviation, ends up with 0.7219. So this 1,000 is not quite a standard deviation above average, but no, it's pretty close there. So then what you need to do is you need to actually figure this out. And because it's a normal curve, you're going to use normal CDF on your calculator. And in case you forget how to do that, you are going to press the second key and then the vars key to get there, to find that. And then how you show this mathematically, because normal CDF is what we call calculator talk, it's not really a recognized mathematical function. Texas Instruments just uses it because that's just what they do on the calculator. What you want to do is you want to go ahead and show your notation this way. So you could write it one of two ways. Either option one would be, hey, the probability that the total cost is more than 1,000, that would work. Or you could also write it as the probability that our z-score is higher than what we just came up with. And then what you do is it ends up being an answer of 0.235. And where that comes from is it comes from using normal CDF. Our right and left boundaries are up here. This is our left boundary and this is our right boundary. So it's always the left boundary comma the right boundary. So it would be normal CDF 0.7219 comma 99. And when you do that, you'll get about 23.5%. So that's how expected value can be used to figure out situations like this, total cost or other things. And it can also be used in a normal model to help us figure out probabilities as well. So that's it for expected value.